Welcome to Cheap Controls. We make videos on things that we struggled with, hoping to help you so you don't. Consider subscribing and hitting that bell. In this video, I'm going to go over sending values from the nextion to the Arduino. And I'm going to send them as values, and I'm going to send them as text, and show you two different ways to accomplish this. I'm going to start in the nextion. I already have it somewhat built out. I have 3 number fields, and they're all set up identical. They're set to be global for their scope, and they're set to have a numeric keypad. You have a choice of none, which is just your basic field which you populate programmatically, or you can have a couple different options for entering data. I've selected the numeric keypad, so this way I can just add the numbers easily. And then I have 2 buttons, and one we're going to use to send the value and one we'll use to send the text. Currently the text one I don't have coded with anything, and the value one is the one we'll start with, and I have it set up with a pretty simple code here where it's just going to send out the serial port val, or the word val, V-A-L, and then it's going to follow with these values. When you send the values, nextion only understands positive integers, and they're up to 4 bytes wide. I can't remember off the top of my head what that number is, but it's a large number, and it's the only number that nextion understands. It doesn't have integers and things like that. I think they might call the value a word, but in the Arduino world it's called a long because it's 4 bytes long. And we're going to send N0, and then we're going to send N1, and then we're going to send N2. And since each one of these is 4 bytes, it'll be 4 plus 4 plus 4, which is 12, and then 3 for the V, the A, and the L. So in the end, we're going to send 15 bytes out the serial port towards the Arduino. I'm going to run this in debug, and I'll show you what it looks like. In the debug window, you have these 2 screens down here which give you some information on what's happening. This one over here is the data that you're sending out, and this little box over here shows you what's coming in. We won't be seeing anything on this because we're just going to have the Arduino receiving data for this. But if I click on these, and we'll set some values. Then we're going to send it. As I said, this one doesn't do anything yet. If I send the value, you see we send 1 long string. If we do it in a string format, it's just garbage because it tries to equate these values into characters, and it can't do that. So we'll just send it as hex. But you can see these first 3 characters, if I do go to string, they say VAL. It can interpret those, but then it gets kind of messed up after that. But if we just stick with the hex, you can see the first 3, and then there'll be 3 sets of 4. So 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. And it starts from left to right, so the values are on the left side of every 4 bytes. And you could send more and add it on, but for this case I've just selected 3. And now we're going to go over to the Arduino and receive the data. I'm going to start with my basic setup for the Arduino. If you've seen any of my other videos, this is the main setup that I have. One of the things you have to keep in mind is I'm using a nano for this, so I have to use a software serial if I want a second serial port, which I do in this case because I want to be able to see data in the serial monitor and send data to the nextion, or receive data from the nextion. So I have it set up like this. If you're using a Mega, you can just comment these 2 lines out and it'll work just fine because there's a serial 2 on the Mega. And I have a note in here about that. Other than that, all the other information is set up just in my default setup to receive data from the nextion. If you'll notice, there are no libraries in this other than the software serial, but as far as the nextion, there are no libraries. In the setup, we just set the serial ports to run, and then I have this pin mode just so I can have an LED flash on the nano itself. And then there are 3 if statements down here. One collects the data that's sent from the nextion itself, and then this is my asynchronous delay, and it just runs, and we can set it up based upon a variable at the top to run. Right now I think I have it set to go every half second so I get my LED to flash. We're not going to be using that in this one. And then down here, when we get this data from display, or DFD for short, up here, if it's coming from the nextion and it's an error, it'll be followed with 3 FFs. And so I just have this down here to collect that. So if the DFD ends with this 3FFs, which end character is defined at the top, then it just prints it out. So I know that there was an error. And once again, I don't think we'll be using this either. So we'll just be focused on this serial2.available. Now for my main setup here, this device here is my USB to serial, and this is what I'm going to use when I use debug in the nextion. I'm going to send the data out that. Then I have it connected to my Nano over here, and then I have this little display here that's going to show the output. And that way we can simulate somewhat of a real-world situation by having a physical example. And then of course I'm infested with flutterbirds, so just have to ignore those for now. And normally I don't like to use libraries, but with that display, that little LED display, I don't want to go through all that right now, so I'm going to add a library. So I'm just going to stick it up here at the top, and this is just a library to make that display work. And I can go into that in a comment. If you want to know the model or the display that I bought, just put a quote in there, or put a comment in and I'll reply to it. And then the other thing is in the setup we have to do some things to make the display work. So in order to make this display work, it just has some commands. We call it display, and that's defined. And then we're just going to clear it. We're going to set the text to a white. You have your choice of white or black. And then we set the size to 1. I'm just setting everything up generic, and we're going to move the cursor in 10 spaces and print cheap controls. If you saw, I already have that set up on here. It says cheap controls. I'm getting some flicker on my screen. I'll be interested to see how it appears on the video. And now we'll move on to the code itself. We know for this example we're going to be getting a string that's 15 characters long. And when we collect the data, we collect it one character at a time, and we just keep adding it to this DFD, or this data from display variable. So if that data from display exceeds 15 characters long, then something's happened, because we should be using it at that point once we've hit our 15 character. So we're going to reset it, because we've hit some sort of error, we've collected too much data. Let's just set it back to blank, and then we can start collecting data again. So I just put this in for an error state. I don't really need it for this example because I could just reset the Arduino, but I put it in there just as a reference. I put a note up here that says that this section is going to be if the data is sent as a value. The way I have this set up is I have it first looking at the substring, or the first 3 characters of the data from display. And if those 3 characters are VAL and the length is 15, because when we collect it one at a time, we could execute this if command the second it gets the first 3 characters. Well, we want to make sure we've collected all the data too. And then I have it set just to serially print on the serial monitor the data from display, the data that we've collected, just kind of as an error check. And then right after that, we're going to clear the display, that little LCD display, or that LED display, and then we're going to run through the steps. And we're going to change the value that it's going to print out to values. So it's going to delete the cheap controls, and it's going to say values. And then when we do the text, I'll have it switch and say text. That way we can see that there's a difference between the two. And this really isn't important because the video really isn't on the display, but I just thought I'd go into that a little bit. Then what's interesting though is the data was going to come over as characters, even though they're values and even though it's a number and the characters aren't readable in any way, they still come through as characters. It's difficult in the Arduino to change a character to an integer. Well, it's not really difficult, but there are some steps that you can do to make it easier. And if you look, and I've got an example of the string over here. We're sending in a V, an A, and an L, and then we have 4 characters which represent the first number, 4 characters for the second number, and then 4 characters for the third number. And we can treat that DFD as a character array. So we can take the third character, and arrays are 0 based, so the V is 0, the A is 1, the L is 2, so the first character is a 3. So we're going to grab that DFD 3 character and we're going to move it into another array. Now we haven't talked about this array yet, and this looks a little bit funny, this value dot character byte 0. But what I'm going to do is I'm going to show you something called a union. And what a union is you can have a character array and an integer long, because an integer long is 4 bytes. And if you have a character array that's 4 bytes, you can have them point to the exact same memory locations. So I'm going to move up to the top and add this union in. And this is what a union looks like. You define it as a union, and then you say what do you want that union to, or what parts do you want it to have. In this case, we're having a character array which is 4 bytes long. I define it here. And then we have a long. And we're going to call the character array character byte because it's a character byte array. And then I was just going to leave this one long, but if I call it long, then it thinks it's the term long, and you can't use that. So I put value long, or VAL long. So this way I have 4 bytes in memory that if I refer to it as this val long, it's a integer or a long value. And if I refer to it as char byte, it's an array of characters. So what I'm going to do is I'm going to take the characters that I'm coming the data from display, and I'm going to copy them into this value character byte. And I'm going to do 3, which would represent the first character, 4, 5, and 6, and move them into 1, or 0, 1, 2, and 3. But then when I print it out, I'm going to refer to the value dot val long. So I'm referring to the long value, or the number version of it. Of course, when you print it, then you want to cast it back to a string. And I'm going to print that out on the serial monitor, and then I'm also going to print it to the display. I have the serial monitor right here, and then I have it still running in debug. I wish that I could expand this somehow, but I can only do it if I stretch this out, and then this doesn't quite match up very well. But we've already gone over what shows up down here. So when I send the value, I have to start it first. So you gotta go down here, start your user MCU. It's connected to COM port 5, and hit start. Now when I send the value, it goes over to the nextion, or over to the Arduino, and I print it out twice because I print out the data from display, and it comes through as garbage because it tries to take those character array and print it out as characters, and it doesn't really know how to do that. But then I also print it down here as the number. So I take it in, I move it into that union, that character byte array, and then we read it out in the long. And if I bring up the camera, you can see that it says values and 1, 2, 3. And so now we're going to add the other values in. And it's as simple as just copying what we have up here. So we just do display value 2, and instead of the 3, 4, 5, and 6, now we'll just use the next 4, 7, 8, 9, and 10. We can write them to that same character byte array because up here we've already used it, displayed it, and printed it. And then we can just display it and print it again. Now for the display to work, just on a side note, this second digit here is the height of it. So I'm going from 8 down to 16, and then for the third value I'm going to go down to 24. And that way it determines where you're writing on the display. But for the value 3, we'll use 11, 12, and 13. Now you could set up 3 separate unions if you wanted to use the data elsewhere in the code or save it for some reason. But for this case, we just set up 1, and we'll just overwrite it. And then even with this case, though, the third value is still stored, and you could use it elsewhere in the code because it will stay there until we overwrite it, because I define the union up in the top, so it's set kind of globally. And then when I'm all said and done, I erase the DFD. If you didn't have this line in here, it would just keep adding to the end. It would never run this loop because it's looking for one that's 15 characters long. Now I'm going to upload this and show you that this works also. So now I've left this just where it was. So now when I hit the send value, we should get, this should look the same, this val up at the top, but we should get the other 2. And we do. And if I pull up the camera, you can see that we get them in here too. So now we'll move on to the text version. In order to make the text work, we're going to send it in a series of strings, 1 for each number on here. And we can't just send the data because we have to send the code in front of it. So when we sent the value, we preceded it with VAL. Well, when we send the text, we're going to precede it with txt. The nextion doesn't allow you to add multiple strings together. You can add 2 together, but not 3. So since we have to do some conversion of a number to a string and then do it all together, we have to use some variables. So I'm going to add 2 variables. We got VA0 and VA1. We're going to set them to string. And we're going to send 8 characters. You could send more because 4 bytes could be represented in a very large number. But for now, we're just going to set it to 8. And we're going to use VA1 for that portion of it. But since we're going to have the 8 characters, and we're going to add txt, and a number to define which field we're sending, we're going to need 8 plus 3 plus 1, which is 12 characters total. So we need to change the length of our VA0, and we'll set it to 15. So that way we have more than we need. And then on the send, we're going to do it on the release. I prefer to do things on the release rather than the press, so I can hold it and maybe do a little discussion before I release. But since we are going to send 3 separate lines, and our DFD, our collection on the Arduino, just instantly collects it, we're going to want to put some delays in between how we send the data. There are other ways to do this, but I don't want to get into that in this video since what we're covering is just how to send the values and how to read in the values. So I'm going to add some delays into this. And TSW is a command that disables a device. So in this case, when we release B1, we're going to disable it. And then that way you can't accidentally tap it twice. And then after 1 second, we're going to enable it again. So we're going to disable it, and we're going to add our code, and then we're going to enable it. And here's where why we need the 2 variables. The first thing we're going to do is take VA0, which is this first variable over here, and we're going to add txt1, because we're going to do this first number box. And then we have to convert it. So covx, there is a cov function, but covx is the new one. And when you use covx, you take whatever field, in this case it's n0.val, and we're going to convert it to text. So you take n0.val and then put a comma followed by wherever you want to place that. In this case, we're going to use that second variable, va1.txt. And then the next variable that you put in, and if I backspace over, it'll bring it up, is the length, and we're going to set this to 8 characters. So that way, even if it's 1 or 2 or 16, it'll be preceded by zeros. So if it was, say the value was 10, it would be 6 zeros, then a 1, and then a 0. And that'll make it so the data is set in the Arduino, and we know what we're looking at. And then finally the format, and we just want this sent for decimal. So we'll just put 0. And then we have to add those 2 values together, or concatenate them together. So we take VA0, and then we add, with the plus equal, adds VA1 to the end of VA0. So it becomes txt1, and then the value. And then we're going to send it out the serial port. I'm going to run this in debug right now to show you before we add the other buttons. So we're going to select this number field up here. We're going to put 1, 2, 3, just like we did in the last example. But in this case, we're going to send it as text. And then what you have here is you have the hex values. And when I went to hex and set it as a string on the value, we got a bunch of garbage because it didn't know how to interpret it. I'm going to send it that way too, just so we have it. So we have our 2 lines. If I change this to a string, the text comes through as txt1 and then the value preceded by zeros. And that makes for a nice readable format. And if you look down here, it's trying to interpret those into characters, and it has trouble doing it, so it's harder to read. And that's one of the nice things about sending it as text. Now we'll go back and add the other variables, or the other number fields. So after we print the VA0, or the first number field, we're going to delay for a second, 200 milliseconds to be exact. And that way the Arduino has time to process the information. You could cram all these together and break it apart in the Arduino, but for this case I don't want to get into that much detail. I just want to show you how one way to read the data in and interpret it. So then we just do the same thing down here. We take that covex, only we use N1, and turn it into VA1 down here, and then smash it together and send it out. We wait 200 milliseconds and we do the same thing, only we precede it by TXT2 and TXT3. So we can look at the TXT3, and that'll determine that we're sending text instead of a value. And then we can look at that fourth character, the 1, the 2, or the 3, and that'll tell us which text field we're looking at. So now we'll move over to the Arduino now that this is all set. I am going to go ahead and start the debug on this, and I'll show you that first, and that way it'll be up when we get the Arduino done. We'll do it just like we did. We'll do 1, 2, 3 for the first one, 4, 5, 6 for the second one, and 7, 8, and 9 for the third one. And then we're going to send it as text. And you can see we get 3 separate strings being sent, and it's text 1, text 2, and text 3, and then the numbers. Now in this if statement, we were looking for the DFD substring of VAL and a length of 15. Well, we're going to do the same thing, we'll just have another if loop. But in this loop, we'll be looking for TXT instead, and we're going to be looking for a length of 12, because we have TXT plus a 1, a 2, or a 3, and then 8 characters, so that equates to 12. And then we're going to print it just like we did before, just for reference. So we're going to make a variable called test, and it's going to be a substring of 4. Whenever you don't put a comma and another value in the substring, it just takes everything that's left. So we're going to go beyond that TXT and the number, and we're going to grab everything else and put it into test, and it'll be a string. And then we're going to do the same thing on the display, only instead of values up above, we're going to put text. So we're going to clear it, and we're going to print the word text atop. Now this is going to run 3 times through here, because we're not checking for that 1, 2, or 3. So the only number we're going to be working with in this case is the TXT3, since we're going to overwrite every time. So you'll see it in the serial monitor because it will print the TXT1, it'll print all 3 up here. But on the display, it may write it so fast you won't see it, you'll just see the last one. We'll add the other 2 variables in when we're done. But for this case, we're going to go ahead and just put in value 3. And we're going to print test. Since it's a string, we'll be able to just print it. And we're going to print it on the serial port, and we're going to print it to the display itself. So we'll run that now. So we'll start our connection. And then we're going to send it as text. I've left this up here so you can see the difference. So you can see it sends text 1 in the value, and then the value itself. It should also be printing it to the display. It's 2 in the value, and the value itself, and then text 3 in the value, and the value itself. Now you see it all in here, but it overwrote it on the display. So I'm going to go to the display now. And you can see that the last one is 000789. Now what's interesting is that when you send it as text, it doesn't get rid of the leading zeros because it's just a text string. So what you do sometimes is you'll convert that to an integer, and then you'll display it, and then you'll cast it as a string to print it, and that'll get rid of those leading zeros. And we'll do that next. So right here where it says string test equal DFD substring 4, we'll just change that. When we bring the characters in, we want to bring them in 4. There's 4 bytes long, so an integer wouldn't be long enough to hold all the data. So we're going to call it a long. And since the nextion doesn't understand signs, positive and negative, it just has a digit, we're going to make it unsigned. And then over here we just take that DFD substring 4 and we convert it to an int. This toInt function built into the Arduino does interpret up to a long. It can do a size, so it's kind of misleading. It says integer, but it will convert it to a long. When we go to print it down here, we do have to cast it to a string because now it's no longer a string, it's a long. So I'll run it again and we'll show you that now you won't see the leading zeros. So I'm going to leave the data the same in this case and just send it again. And this part should be the same because at this point it's still a string, this text 1 and then the value. but the value under it now shouldn't have the leading zeros. And you can see that they're gone. And now I'll bring up the display again. Now we're still only showing that third byte, so we'll add the other two into the display next. But you can see that it got rid of the zeros. In order to add the next two values, since we're sending three separate strings, we're going to have to store them. There are other ways to do this, but I'm going to go ahead and do it with a couple of extra strings. So we're going to go back up by the union, where we define this union up here. And I'm going to add two unsigned long variables called text1 and text2. We won't need the 3 because we'll use the test variable for the 3. Now we'll go back down into here. I don't want to display the data every time we meet this criteria, because we're going to meet this criteria every time we see a txt. The only time we want to display this data is when the fourth character in this is a 3. So the first two times through, the txt1 and txt2, we just want to load some variables, and then we'll just make one display. If you write to the display that I'm using, you'll see a flicker. So you want to minimize the amount of times that you write to the display. I'm going to show you this in a couple of steps, so you won't see much difference here. But what we're going to look for is if this DFD substring, the fourth character at the 0 base, so 3, 4 is equal to a 3, then we're going to run this display down here. So the first couple times through it, in this case, since we're not doing anything with them, it'll do nothing. It will just print it. And then we wouldn't get those other writes to the screen. So I'm going to show you that now. When we ran it the last time, we saw txt1 and then the value, txt2 and the value, and txt3 and the value. In this case, we should see the txt1 and 2, but we shouldn't see the values written underneath it because it's not going to run that portion. And you can see that's exactly what we get. So what we're going to do is we're going to store these into variables and then print them after we've collected this third one. So right up here, we're going to add these two lines. So if the substring, if the fourth character is a 1, then we're going to make the variable txt1 equal to test because we've collected it here. And then these two won't equate to true, and then it'll exit. And then the next time through, when the substring txt, the fourth character is a 2, we'll write test, the value we collected, to txt2. And then that way, the third time when it comes through there, we'll have these variables, and then we can display everything at once. So right before we display this 3, we'll add the other 2. So we'll serially print text1, which we added up above, and we'll display text1, and we'll also move our character down on the display to 8, 16, and 24 as we write the data out. And now we should see all 3. So now over here on the serial monitor where we wrote the 3 values but we only displayed the 1, now we should write all 3 of these out and then display all 3. And that's what we get. And let's just change this value here. And I'm going to bring up the camera. And it'll go behind when I push the button, and these should change. And you can see that it works. And if I switch to the value, you shouldn't see any difference here other than the value at the top. So you still get the values. And we're just sending it at different ways and interpreting it different based upon a signal that we're sending. Just for a quick review, when you're sending data from the nextion display, if you're not going to use the built-in libraries, which I never do use, you're going to want to add some sort of a key to it so that you know what it is you're sending, and so the Arduino can see something and then know that there's going to be data after it, and that way it can better utilize the data that's being sent. And when you're sending this value, or rather than a string, the best way I found to do it is to use this union. Now a union can be confusing, and if I had enough comments below, I'll do a video specifically on unions, but they're not horribly complicated. You just create two things that are of the same length in memory, and you define them as a union, and then depending upon which one you call, you either call it as a number or you'll call it as a character. And so it can be very helpful, and if you just use them a couple of times, they get pretty simple. And then when you're sending the text form, I have it split up into 3 different strings. But I'm going to go back to the nextion for this. Now in the nextion, the way I sent this was I took this N0 and I concatenated the value with txt1. And then I did the same thing down here with txt2. But you could, knowing that there are 8 characters each, you could send text txt, and then you could just concatenate each one of these onto the end of it, and then you would know that it's 8 characters. Just like in the value we knew that each one was 4 characters, then you could read out the data that way also. So you have a couple of options on how you send it. I just thought for the example of this one it was easier if I broke it out into individual steps. But once again, like the union, if I had a lot of comments and someone said, I don't understand what you're saying about putting that together, I could put a part 2 out on this video and do it that way. So feel free to put your comments below and let me know what you think. A side note, I bought 2 of these LCD displays with some of the money I got off the Ko-Fi donation, so I really want to thank people for donating to that. I also bought a digital power supply that I'm interfacing with the nextion, and I'm going to try to do a direct connect between the two. Even though the DPS power supply says that it has a 3.3 volt and the nextion is 5 volts, I'm going to try to incorporate some isolation between the two and make some videos on it. So I just want to let people know what the donations go to, and it's been a lot of fun getting that and then playing with the devices, so I really appreciate that. Well, that's about it for this video. If you like what you saw, consider giving me a thumbs up, and also consider subscribing to the channel. Thanks for watching.